Hello and welcome to the second part of the Physics Paper 3, KCSE Physics Paper 3, which is the practical paper. We have already discussed the various aspects of that paper, like for example, how you write down raw measurements, how you go about writing down values in the table, the number of significant figures that you use, the number of decimal places that you use in the table. We have discussed that. And if you've not seen the first part of the physics KCSE physics practical paper, please look for the first part so that you're able to follow this particular part. In this video, I'm going to discuss the rest of the paper, which is the graphical solution or the graphical analysis of the data. We have already collected the data of t squared versus L. So that is where I want to start from that. And then after that, you'll be given a series of questions. Like for example, one of the questions that you might be told, you will definitely be told this: plot a graph of this quantity versus this quantity. What does that mean? For instance, here, we've been told to plot a graph of t squared versus or against L. The first physical quantity which is mentioned always goes to the y-axis. The first physical quantity which is mentioned always goes to the y-axis. And if you are in doubt, the physical quantity which goes to the y-axis is always the dependent variable. The independent variable goes to the x-axis. But you don't want to worry yourself at this point about dependent and independent variables, because the examiner has given you clear instructions on what goes to the y-axis, what goes to the x-axis. Sometimes they go ahead and say, plot a graph of t squared, then in bracket they say y-axis against L. Of course, L will go to the x-axis. But just in case that is not given, always understand the first physical quantity which is mentioned goes to the y-axis. So let's look at the table. Here we've got the table of t squared versus L in meters. Now when you look at the values of L, they range from 0.9 all the way to 0.4. You can say 1 meter to 0 meters. So that is the range. You want to spread those values on the x-axis. Okay, so you'll have to look at the space given and then start counting. Like for example, here on the x-axis, you might start counting like this. If the whole of this is the paper which is given, then you might start counting like, you start from here. Maybe you go slightly inside here because you'll have to draw the x-axis and the line for the y-axis. Do not draw the y-axis too much on the inside. Neither should you draw the x-axis again too much on the inside. Always leave about 1 centimeter or 2 centimeters. Here I've left 2 centimeters because I can see on the top side also there about 2 centimeters. You want to fill as much of that space as possible with the graph. In fact, the rule is your graph or any one of the axes must occupy at least 3/4 of the space given on the x-axis and 3/4 of the space given on the y-axis. That is usually the rule. But just bear in mind that your graph must be big enough, large enough. So I'm talking about spreading the values all the way from 0 to 1 meter. So I might go like this. I might say this is 0, and then I go to 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, 1. Okay? And my graph will reach somewhere here. But I can see there is still a lot of space given here. That is why I said, okay, instead of going at intervals of 1 centimeter, let me go at intervals of 2 centimeters and see whether it will fit. So I start from here: 0.1, 0.2, 0.3, 0.4, 0.5, 0.6, 0.7, 0.8, 0.9, exactly 0.9. So I could see that it's going to fit. If I were to choose any other scale, then I might find that some values don't fit within the space which is given. So what is the first step in choosing the scale? You've got to look at the smallest value in the table and the largest value. In this case, I've made the smallest value to be 0 because I want to start from 0, 0 from the origin, and then the largest value to be 1 meter. 1 meter. I go beyond the boundaries. Go beyond the boundaries so that whatever value that I get, I'm sure they are going to fit there. And at the same time, I want to spread them so much so that they fit in the space. While you're deciding to do this, there are some numbers that you might want to avoid. A number like 3, a number like a multiple of 3, which is 6, and 9, a number like 7. 7 is in fact one of the worst numbers. Best numbers to use will be 1, 2, 5, and a multiple of those numbers. That is 10, 4. If you choose 2, you can choose 4, you can choose 8. If you choose 1, you can choose 5, you can choose 10. But avoid numbers such as 3. What do I mean by avoiding numbers such as 3? If, for example, I decide to make that, let this distance from 0 all the way to this point to be 0.3, for example, I'll have to divide that 0.3 by 10 because there are 10 spaces to find that one space is 0.03. That one is a very odd number because it doesn't fit into 5, it doesn't fit into 10. So the simplest rule is this: avoid numbers such as 3, avoid multiples of 3, which is 6, 9, avoid 7. Numbers which are best to use will be 1, 4, 5, and their multiples. And that is exactly what I've done. I've decided to use 1 throughout. What does that mean? This is 1, this is 2, this is 3. If I divide that 1 by 10, I get 0.1, 0.2, 0.3, and so forth. So I'm moving in steps, or you can regard this to be like the least count. I'm moving in steps of 0.1, 0.1, 0.1, 0.1. Now when I look at 0.1 here, there are 10 spaces here. So I divide 0.1 by 10, I get 0.01. So the value of one small space over here is 0.01. That is why I add this 0 to 0.1 to show that it's possible to read the second decimal of the value of length. In other words, it would be possible to read 0.01. 0.01. Let's go to the y-axis. I did the same in trying to spread my values all the way from 0 all the way to about 3.7, and I made it to be 3.8. Yeah. Again, I counted, and the best counting that I could be able to come up with is something like this. That means from here to here is 0.2. That means that it's possible to divide 0.2 by 5, and I get 0.04. So one small division here represents 0.04. Remember, this one is very important to obtain the value of one small division on each scale, because it will allow you, once you've gone back to the table and rounded up the values in your head. What does that mean? What does it mean to round up values in your head? Let's look at this first value here. This is 0.9. We are able to plot that exactly, or to identify that exactly on the y-axis. But when it comes to the x-axis, it is 3.663. You find that this scale that I've chosen, 3.66, enables me to plot up to the second decimal of the value of t squared. The second decimal of the value of t squared. So you will have to round it up in your head. You don't have to write down in the table that what I'm plotting is 3.66. No. Now, how do I identify 3.66? I'll come to this one here and say, okay, one division is 0.04. So this one will be 3.64. The next space will be 3.68, and I can see that I've gone beyond that, so it must be 3.66. 3.66 is between 3.64 and 3.64. Just a minute. This is 3.64, and then this one will be 3.68. So our plotting of 3.66 will be between 3.64 and 3.68. So it is somewhere in between here. And when you look at that value, that is where I've tried to do the plotting. There are two types of plottings that you use. You can use a dot and a circle, or an X and a circle, or just an X. So I've decided to use an X and a circle. And you can see that the plottings are quite clear. One other thing that you should be careful about is that when you're plotting these values, ensure that your pencil is sharp, and it is one of those pencils which gives intense dark color. Don't choose some of those pencils in the market whereby when you write, it becomes very difficult for the examiner to see what you're writing down on the paper. Don't go for those types of pencils. It is important that you make anything that you write down legible, including your handwriting. Some students don't use legible handwriting, and the markers really don't have time to try and guess what you wanted to write down. They don't have time to do that. It is your responsibility to make sure that everything that you write down is clear, is very, very clear. Print whatever you are writing down very well. Separate the letters so that your words are very clear on what you're writing down. Don't always write in a hurry, given that majority of the time during the examination you'll find that students are stuck and they are not writing down anything. Why don't you use that time to make sure that your handwriting is as clear as possible? Okay, fine. I've gone beyond the first point. The first point which you need to take care of when you're plotting the graph is to, first of all, draw the y-axis. This is the y-axis, and this is the x-axis. You draw those lines. And remember, for you to be able to identify where you draw them, you've got to first of all determine the scale. You don't need to write the scale down. The examiner can be able to see that this interval has not been, you've followed your interval very well. So if you started with 0.01, we expect in the next 2 centimeters, it should go in steps of 0.1, in steps of 0.1. Similarly, for the y-axis, make sure that your values fit and they occupy at least 3/4 of the space which is provided there. Having said that, you come now and draw this x-axis and the y-axis. Next, you are going to label the axis. Labeling the axis means you put the physical quantity and its unit in brackets. Very important. You always get 1 mark for labeling the axis. Half of the marks will go for labeling the x-axis, the other half will go for labeling the y-axis. But sometimes you lose that mark totally if one of them is not labeled correctly. You lose that 1 mark completely. The other mark is for choosing the correct scale, a working scale, a suitable scale. I've already warned you against numbers that you should avoid using. Next, for 2 marks is plotting the points. You should plot the points from the table exactly the way they are in the table. Even if there are errors in the table, transfer those points to the table because you do not know whether they are wrong or correct. But so long as they appear in the table, transfer those points from the table and plot them on the graph. Next is about now drawing the best fit line. Now, how do you know that this one is a curve and not a straight line? There are certain pointers in the question that tell you to do that it's a straight line. When you look at the questions that you've been asked, find the gradient S of the graph. If you find that question, find that statement, find the gradient or find the slope, they may give it any symbol. Usually they use S. Find the slope S of the graph, or find the gradient S of the graph. If you find that sentence, it implies that the graph you should have got is a straight line. Next, does this line pass through the origin or not? You'll have to look at the equation given. Because if you determine that it's passing through the origin, then you know one of the points is the origin. Although you are not supposed to plot that point, but you know at least your graph will pass through the origin. And that is what I did. I have to align my best fit line with the origin, and then struggle with the rest of it, because I do not want any kind of intercept here. So if you want to know that whether your graph passes through the origin or not, you look at the equation which is given. You see whether it is in the form of y is equals to mx plus c. If you see that your graph is in the form of y is equals to mx, there is no c, then you know it passes through the origin. But if there is some kind of intercept, which is c, then you know you've got to get the y-axis, the y-intercept at some point. In our case here, when we look at the equation which is given here, even after you separate the variables so that you can get t squared and L separated, then you can see that the graph is, this quantity here is t squared, it goes to the y-axis, L goes to the x-axis, and you can see this is the m, So our graph is y is equal to mx. This goes to the x-axis and this goes to the y-axis. This is what we call separation of the variables. You have separated the variables. You have clearly said this goes to the y-axis and this goes to the x-axis. You have separated them. Anything else that appears in that particular equation should either be equal to the y-intercept or the gradient. That is the beauty of it. Once you separate you write down the equation starting with the physical quantity that you had on the y-axis. You start with the equation that you had on the with the physical quantity that is on the y-axis. Once you start with that, and then you make sure the physical quantity on the x-axis is also separated from any other constant, then you're on the right track. You have separated the variables. Like here, I've already separated them. T squared, y-axis, L on the x-axis, then it means 4 pi squared over g is equal to the gradient. But we have not come to that. Let's go back here. After you have plotted your graph, you have plotted the points, you need to draw the best fit line. Let me emphasize a few points about the best fit line. What are the points that you look for when you are drawing the best fit line? First of all, this is the reason why in the exam you are asked to carry along a 30 centimeter ruler which is transparent, so that the moment you put it above the points, you can be able to see those points which are covered by the ruler and those points which are not covered by the ruler. You twist your ruler carefully until you can see that your line passes through majority of the points. Your line, straight line, will pass through majority of the points and leaving out some points. It may pass through all the points if you are very accurate, which is hardly the case. So those points that it leaves out, you ensure that the points it leaves out, you arrange them in such a way that there are some points above the line, some points below the line. And when you look at my line, it passes through this point, through this point, through this, very close, through this, okay? And remember, one of them that I determined, although I don't plot it, is the origin, because I can see that graph passes through the origin. So I have to make sure that it passes through here. So when I put my ruler, I miss out that and miss out this. Notice that the distance, one of the points is above the line, the other one is below the line. is on this other side while this one is on this other side. They should be equal in number. Therefore, 1 point above, 1 point below. If there were 4 points, then I should make sure that 2 of them are above, 2 below. Sometimes you may even draw the best fit line in such a way that it doesn't pass through any of the points, but it has left equal number of points above and equal number of points below. That one is very, very important that you observe. And then you make sure that the line that you want to draw is at equal distance from each of the points. Those are the skills that you need to use when you are drawing the best fit line. Okay, so after that, you draw one continuous line. So because my data was starting from 0.4 all the way to 0.9, I can't continue with a solid line here, because continuing with a solid line here means that these points which are not there were actually obtained in the table. That is not true. So what I've done here is to dot my line backwards. We call it extrapolation. Remember, drawing a solid line means that those points were actually obtained in the practical, which is not the case. So always extrapolate your graph by using a dotted line. Those are the rules that you follow when you are drawing the graph. Number 1, label the axis, because without labeling, you miss one mark. So label the axis. Number 2, choose a suitable scale. I've already explained that. Number 3, plot the points exactly the way they appear in the table. You plot them in the graph paper. You get 2 points for that. You've already earned 4 points. The last point is for drawing the best fit line. And remember, for you to know that it's a line, you look at several pointers. Have they asked you to calculate the gradient of the graph? That is one of the pointers that you look for. The next thing is that you look at the equation. There are 2 things you gained from here. You confirm that it's a straight line if an equation is given. And next, you confirm that whether this graph has an intercept or no intercept. I've already explained that. If you find for some reason that they've asked you to find the gradient at a given point, maybe they ask you, find the gradient when L is maybe 0.5. This is the first pointer that your graph may not be a straight line. Find the gradient or the slope at a given value of x. This is an indication that your graph is not a straight line. It may be a curve. It may have a certain turning point. Or find the maximum value of this. Find the minimum value of this. So if they ask you for the maximum value, then you know it's a curve which goes like that. If they ask for a minimum value, then it's a graph which goes like this. Those are some of the pointers you know whether it's a straight line or a curve. But most of the graphs you get in our physics practical are always straight lines. But don't lose sight of the fact that a curve could come along as one of the things which is required. Next, the next question is that they will ask you to calculate the slope of the graph. The slope of the graph. Once that has been asked, make sure that the graph which you draw, you go and draw this right angle triangle in order to get the change in the quantity on the y-axis and the change in the quantity on the x-axis. So this one is no different from what you do in mathematics. Delta y over delta x. Only that in delta y, it becomes delta t squared. And delta x becomes delta L. That is what we have. So in delta y, it should be delta t squared and delta L. Now, once you've drawn that right angled triangle, you must dot this particular point here. You dot it backwards like this in order to find x, to find y2. Because delta y is y2 minus y1. That is how we do it. While delta x is x2 minus x1. So you must find the value of y2. So you find it there. You find y1 and then you find delta y is y2 minus y1. Similarly, delta x, or in this case delta L, is x2 minus x1, or L2 minus L2, because it's delta L that we are looking for, and the value on the x-axis is L. You must show those dotted lines. You must show the triangle. The moment the examiner sees that you are attempting to give the read-offs on the graph, already you've earned 1 mark out of 3 marks for calculating the gradient. 3 marks may be given, 2 marks may be given, because sometimes they ask for the gradient and the intercept. It depends on the kind of paper. So don't worry about the marks. You just do exactly what you've been asked to determine. All right? So, and then when it comes now to writing in the space which is provided, show the read-offs. Show these values, this minus this, this minus this. Don't just use a calculator and just write this final answer. No, show that you have read this, because the examiner is going to confirm whether that is the value you've used, whether these are the values that you've used in order to get this and in order to get that. Next, your gradient must have units. Even if the paper does not require you to do that, always derive the units of the gradient, because you are dividing one physical quantity on the y-axis by another physical quantity on the x-axis. So, similarly, the units should be derived the same way. For example, the quantity on the y-axis is t squared with units seconds squared. The quantity on the x-axis is L, length, with units meter. So the SI units of that gradient will be seconds squared per meter, or second squared slash meter, like I've already shown there. So once you've done that, now you've been given the equation there, you have rearranged it in order to find the gradient. Once you determine that the gradient is like this one, 4 pi squared over g, I'm assuming here you don't have manipulation problems when it comes to making a certain letter to be the subject of an expression. Go through that particular topic in mathematics, and this one will be a very easy thing. Once you know that the gradient is equal to this, then it's up to you now to either make whatever you've been asked to calculate to be the subject, and then you go on and substitute, like I've done here, to get the value of g to be 9.634 meter per second squared. And again, you can see that my values were very, very accurate, because the value of g is 9.81. So if, for example, it's given that it should be plus or minus 9.8, plus or minus maybe, is it 0.5? Plus or minus 0.5, I will be within the range which the examiner has given. Again, in the calculation, I've tried as much as possible to keep my calculations to 4 significant figures. 4 significant figures. I've already talked about this and the need to do that. So this is how you ensure that the practical works for you, that you are trying to garner as much marks from the practical paper as possible. Those are some of the rules that you need to follow. If you find that there is something in this paper that I've not covered, although I believe I've covered the majority of the points, just write down in the comments below. Ask me to explain something, or maybe to cover a particular, graph with a certain equation, because I intend to add that as part 3 of this KCSE practical paper. So look out for KCSE paper 3, physics practical part 3, where I will cover more on this area. And remember, what is the percentage that we are trying to fight for? 40%. 40 marks, because the raw marks that you get in the practical paper, they go as raw marks when they are added on to paper 1 and paper 2. No further manipulation is done to those marks. So why don't you make up your mind to score as highly as possible in the practical paper? I've just covered one of the questions. The second question is also similar. Okay, maybe next time I'll cover electricity, because electricity, I know many students have got challenges when it comes to electricity. So again, look out for KCSE Physics practical paper, that is paper 3, part 3, where I will cover more aspects of the practical paper. See you then.